Hey everyone, so today's going to be the first day of our video lessons for science class. Now, over the last 8 months, we've had biology lessons, chemistry lessons, geology, and physics, and now we've got time for one more somewhat brief unit, but hopefully we'll get through everything, and so we are going to be doing astronomy for this last month of school. Now, obviously, because there is only a month left and because we've covered so much other stuff, only half the month, or like 2/3 of the month, is going to actually be astronomy, because I do want to leave a little bit of time to give you guys a final exam. So that final exam, it's not going to be too hard. I'm going to give you guys the details as we progress through the month. But basically, we're going to be talking about astronomy for a few weeks. Everything will be done through video lessons up here on the board. And if you have any questions, obviously I'm not in the classroom to answer them. So either whichever teacher is in the classroom with you, either get them to send me a message with the questions, or if you're on YouTube, leave a comment or send me an email. You guys all have my email address. Now, in just before the break, we all did our astronomy presentations. So we've already sort of started talking about astronomy, and we're going to talk about some of those things again, some things about the planets and the sun and the moon. You know, as you can see, all of this is stuff that we've technically already talked about in your presentations. But we're going to go into a little bit more detail, just to, get some of the numbers straight, and then we'll move on to some of the more complicated things like, how stars die and how black holes form and what makes black holes terrifying monsters of the universe. So we're going to get through all of that, and eventually we'll get to some more advanced astronomy that I think we'll finish the year with. Is just a little bit of extra astronomy after your exam, but you're not going to be tested on any of that. So that'll just be kind of for fun. Don't need to take notes, but just for those of you who are interested, because I know a lot of you were waiting for this unit. Alright, so we're going to start something fairly basic, the solar system. Now, the solar system has not that many components to it. It's not that complicated once you've stared at it for a few minutes, or in my case, a few years. But basically, the solar system is composed of one star, which hopefully we all know, 8 planets, and I'm going to say 5 dwarf planets. There are more than that, but we're going to be talking about 5 kind of main ones. So if you notice here in our diagram of the solar system, I do have these 2 extra bits, this right here and this over here, that we never talked about. So we're going to end up discussing those at some point today. But we are going to start off by just quickly going through and labeling everything that's here on the diagram. So we start off obviously with the sun at the center of the solar system. I haven't drawn everything here exactly to scale, but I've sort of done my best. The sun is, because it's so big, I've only drawn a small section of it here. But then we'll just go in order and label all the planets. So we start with Mercury, which is the smallest planet and the closest to the sun, which hopefully you remember from our presentations. Next, that looks like a Y. Next is Venus, which again, if you remember, is the hottest planet in the solar system, followed by Earth, and Mars. And we're going to be grouping all these planets together a little bit later and looking at some of the similarities they share with each other and differences they have from other objects in the solar system. So these are the first 4 planets. This is kind of our local neighborhood within the solar system. You could say the solar system is our galactic neighborhood, but within the solar system, these 4 objects are fairly close to one another. So yeah, the objects themselves are drawn roughly to scale. The distances, absolutely not. So beyond the Mars, right here, we have the asteroid belt, which we didn't really discuss in class so far, but we will we'll talk about it a little bit at some point in these lessons. So the asteroid belt is kind of a dividing line between the first 4 planets and the next 4 planets. And if you notice, the first 4 are very, very different from the next 4. These 4 are all really small and kind of close together. These 4 extend way off into the distance in the outer solar system, and they're all much, much bigger. We're going to talk in a few minutes about how the composition of all of these is also really different, but first we'll just go through and finish naming them. The 5th planet from the solar system is Jupiter. It's the largest, it's the heaviest, and it has, I haven't drawn anything on it here, but it does have an absolutely massive storm as well, which is really interesting. It's been puzzling scientists for a long time. So we'll talk about that as well. The next planet out is Saturn. Everybody can recognize Saturn because of its rings, but it's not the only planet in the solar system with rings. I've drawn 3 planets with rings here. Jupiter also actually has a really thin ring around it, but it's so hard to see that even, space probes that go and visit Jupiter, you never really see a ring system there. It exists, but you wouldn't recognize Jupiter because of its rings, is maybe what I'm trying to say. Saturn, definitely recognizable from its ring system. These 2 also, you don't really see the rings very much, but they are there. So the 7th planet from the Sun is Uranus, or Uranos, if you want to go with the name of the Greek pronunciation of the god. And then the last one, right here, is Neptune, which is the most distant planet from the Sun. So these are the 8 planets of the solar system. We have the asteroid belt right here in between Mars and Jupiter, but then there's another belt out here beyond Neptune, and this is called the Kuiper belt. And it's got a little bit of a weird spelling. It's Kuiper, the Kuiper belt. So the asteroid belt and the Kuiper belt are similar in terms of kind of the size of objects that you might find there, but they do have their differences between them as well. Now, because the planets, the first 4 planets are so different from the next 4 planets, these 4 are often grouped together into what are called the terrestrial planets. So these 4 are the terrestrial planets. Obviously, I've written the Sun, but the Sun's not part of this. So the terrestrial planets include Mercury, Venus, Earth, and Mars, and that's it. That's where it stops. You may, in textbooks, also see these called the rocky planets or the inner planets. Inner planets, I think, is maybe more common, just because it makes a lot more sense. You don't need to know anything about the composition of the planets to know that they are in the inner solar system. So as a comparison to that, I'm going to get rid of this now. I'm not going to test you on the number of dwarf planets in the solar system. And I'm also going to move the asteroid belt. So we have our 4 inner planets, and we have the asteroid belt. Alright, now moving on. The next 4 planets, Jupiter, Saturn, Uranus, and Neptune, these constitute, you can call them a variety of things. You can call them gas giants or Jovian planets. I'm going to go with gas giants because when I was growing up, this is what I called them. We had the terrestrial planets to the inner solar system and the gas giants out there. Now you might also see Jovian planets. You might see outer planets. So we have the inner planets and the outer planets. Sometimes you'll see rocky and gas, or terrestrial and Jovian. So it's not always that you'll see inner planets and outer planets in a textbook. Those 2, yes, but you might see terrestrial planets for the inner ones, and then you might see the same textbook called these 4 gas giants or Jovian planets, or maybe something else. So basically, these 4 are small, and as you can guess from this alternative name down here, they are rocky planets. These four are much larger, hence the term giant, and they have huge atmospheres, hence the term gas. So they're very large planets with huge atmospheres. They're basically balls of gas. And these four are very different from those four. They're a lot bigger, they've got a lot more gas, but they're also made of different stuff. So some of these ones, there's an idea that they have rocky kind of inner cores to them, but then just enormous atmospheres outside of that. But still, the actual composition is different. So these ones are generally made of rock and metal. I'm going to erase this now. You don't really need the diagram. If you've drawn the diagram, then great, but you don't have to worry too much about that. So, the inner planets are made of, generally they're made of rock and they're made of metal. So a kind of a combination of rock and metal. That's the other thing that you could say about them. I mean, they are rocky and metallic, but the other thing that's sort of characteristic about them when you're comparing them to the outer planets is that they're really small. So they're not, it's not that Earth is a particularly small planet. We don't have any shortage of space here right now. But if you were an alien entering the solar system, you wouldn't really notice Earth or any of the inner planets because Jupiter and Saturn kind of dominate the solar system. So if you were, in the next solar system over and you were trying to take a picture of our solar system, you'd have a really hard time trying to actually see Earth. But you might snap a picture of Jupiter or Saturn, or just, a smudge that's supposed to be Jupiter or Saturn. So compared to the outer planets, the inner planets are definitely small. They're made of rock, they're made of metal, and they're not that big. The outer planets are, I'm going to write this down here, they're made of gas, or they have very large atmospheres. I'll put that in brackets, that they have large atmospheres. They're way bigger than the inner planets, than the terrestrial planets. So they're way bigger than the terrestrial planets, and there's an abundance of hydrogen and helium in the outer solar system. So Jupiter and Saturn are made of mostly hydrogen and helium with trace amounts, just a little bit of other stuff. So if you want the full words, then this is hydrogen and that is helium, which hopefully you remember from our chemistry unit. Now, the outer planets, sometimes they get broken up into two categories. You can have the outer planets that, when I was growing up, the outer planets were all just Jupiter, Saturn, Uranus, and Neptune. But now you might see more often that the outer planets are actually split into gas giants and ice giants. And so basically the difference between gas giants and ice giants is gas giants is just Jupiter and Saturn. Ice giants is Uranus and Neptune. Gas giants, Jupiter and Saturn, are made mostly of hydrogen and helium, whereas Uranus and Neptune, they have those elements there, but they also have things like water, ammonia, and methane. which are termed ices, hence the name ice giants. So you might see inner planets or terrestrial planets, gas giants and ice giants in a textbook. So the inner planets would be Mercury, Venus, Earth, Mars. The gas giants, Jupiter, Saturn, and then the ice giants, Uranus and Neptune. We're going to continue this in part 2 in just a second.